Let's solve this physics problem about a car's motion. A car starts moving rectilinearly, first with acceleration w equals 5.0 meters per second squared, with initial velocity equal to 0. Then it moves uniformly, and finally, decelerating at the same rate w, comes to a stop. The total time of motion equals tau equals 25 seconds. The average velocity during that time is equal to v average equals 72 kilometers per hour. The question asks, how long does the car move uniformly? Let's begin by setting up our approach to this problem. We can divide the car's motion into 3 stages. First, acceleration from rest to a certain velocity v. Second, uniform motion at that velocity v for some time t_2. And third, deceleration from velocity v to a complete stop. Our goal is to find t_2, the time during which the car moves uniformly. Let's identify what we know from the problem. The acceleration and deceleration both equal w equals 5.0 meters per second squared. The initial velocity is 0. The total time is tau equals 25 seconds. And the average velocity is 72 kilometers per hour, which we need to convert to meters per second by multiplying by 1,000 divided by 3,600. 72 kilometers per hour equals 20 meters per second. Now, let's analyze the motion in detail. During stage 1, the car accelerates from rest. Since acceleration is defined as the rate of change of velocity with time, we know that after time t_1, the car will reach a maximum velocity v_max equals w times t_1. This gives us v_max equals 5.0 times t_1 meters per second. For stage 3, since the car decelerates at the same rate w and must go from v_max to 0, the time required for deceleration t_3 equals t_1. The total time constraint gives us t_1 plus t_2 plus t_3 equals 25 seconds. Since t_3 equals t_1, we can rewrite this as 2 times t_1 plus t_2 equals 25. Now, let's calculate the average velocity. Average velocity is defined as the total distance traveled divided by the total time taken. The total distance traveled is the sum of the distances in all 3 stages. We can calculate these areas in our velocity time graph. For stage 1, the distance is the area under the acceleration curve, 1/2 times v_max times t_1. For stage 2, the distance is v_max times t_2. For stage 3, the distance is the area under the deceleration curve, 1/2 times v_max times t_3, which equals 1/2 times v_max times t_1. So the total distance equals 1/2 times v_max times t_1 plus v_max times t_2 plus 1/2 times v_max times t_1, which simplifies to v_max times t_1 plus v_max times t_2. Now, we can calculate the average velocity. Average velocity equals total distance divided by total time, v_max times t_1 plus t_2 divided by 25 seconds. We're told that the average velocity is 20 meters per second, so 20 equals v_max times t_1 plus t_2 divided by 25. Substituting v_max equals 5.0 times t_1, we get 20 equals 5.0 times t_1 times t_1 plus t_2 divided by 25. Multiplying both sides by 25, 500 equals 5.0 times t_1 times t_1 plus t_2. Simplifying, 100 equals t_1 times t_1 plus t_2. From our time constraint, we know that t_1 plus t_2 equals 25 minus t_1, which is the same as 25 minus t_1. Substituting this into our equation, 100 equals t_1 times 25 minus t_1, which expands to 100 equals 25 t_1 minus t_1 squared. Let's solve this quadratic equation for t_1. Rearranging, we get t_1 squared minus 25 t_1 plus 100 equals 0. Using the quadratic formula, t_1 equals 25 plus or minus the square root of 625 minus 400, all divided by 2. This simplifies to t_1 equals 25 plus or minus 5 square root 5 divided by 2. So t underscore 1 equals either 5 or 20. Let's analyze these two values. If t underscore 1 equals 5, then t underscore 2 equals 15. If t underscore 1 equals 20, then t underscore 2 equals negative 15, which isn't physically possible. Therefore, t underscore 1 equals 5 seconds, and t underscore 2 equals 15 seconds. So our answer is, the car moves uniformly for 15 seconds. Let's visualize our final solution. The car accelerates for the first 5 seconds, reaching a velocity of 25 meters per second. Then it moves uniformly at this velocity for 15 seconds. Finally, it decelerates for another 5 seconds until it stops. We can verify our answer by checking that the average velocity is indeed 20 meters per second and that the total time is 25 seconds as required.